So in lexicographic preferences, the word lexicographic, can you guys see the screen?
Yes, sir.
Okay, so the word lexicographic comes from dictionary, and it basically means arrangement of words in a dictionary. So it happens in an order. Okay, so a very good example is obviously dictionary, but an easier example to understand lexicographic preferences is the Olympic gold medal tally. Olympic medal tally. So luckily for all of you, recently Olympics were, so you know how it works. So the idea is the ranking, it depends on how many gold medals you have, which after that, what matters is number of silver medals and then number of bronze medals. Okay. So if country one has, let's say, country A has, let's say, 1 gold medal, 0 silver, 0 bronze, and country B has 0 gold medals and let's say 100 silver and 100 bronze, A would still be preferred over B. Right? So this is the simple algebra of it all, that the country with larger number of gold medals will be more preferred. Now, if some other country C has, let's say, 0 gold and 101 silver and 0 bronze, then you would have C also preferred to be. Okay. So what happens is first you look at gold medal and who's leading here. Okay, so clearly A is leading. Okay. Then after that, once you have decided about A, you look at, so there's a tie when it comes to gold medals. So then you look at silver. So usme you see who's higher, and then you look at bronze. So suppose there's another country D, which has 0 here, 100 here, and 99 here. Right. So if you compare B and C now, if you compare B and C, you can see that this is same, but here country B is leading. So that's how it works. Someone has their mic on, so if you can switch it off, the quality of the recording would be better. Okay. So now, why lexicographic preferences became very famous, very popular with these exams is because lexicographic preferences cannot be represented as utility functions. So can you tell me the 3 properties with preferences needed to obey in order to be represented as utility functions? Do you remember those 3 properties?
So completeness, transitivity.
Very good. And completeness, transitivity, and the third one is? Okay, the third one was continuity. So at that time, we talked about completeness. Completeness means given any 2 bundles A and B, either this will be true, or this will be true, or this will be true. And exactly one will be true. Transitivity implies that if you have A weakly preferred to B and B weakly preferred to C, so this will imply A weakly preferred to C. Continuity, at that time, we just said that given any 2 bundles A and B, such that A is more preferred to B, so if you construct a small neighborhood around A and take a new bundle A prime here, and a small bundle around B, neighborhood around B, and consider bundle B prime here, and this would imply B prime is also strictly preferred to A prime. So in a nutshell, what we basically said is that small tweaks leaves preferences unchanged. Okay, so if you prefer one pizza over one burger, then if I remove a little bit of the pizza, it does not make you say that one pizza is now less preferred than a burger. But if I remove, let's say, half of the pizza slices, then obviously it can be like one burger can still fulfill your appetite, but one pizza might not. So in that situation, it can happen that you prefer burger over half a pizza. But for small changes in the bundles, the preference ordering remains the same. So that's the idea. Small tweaks will remain preferences unchanged. It leaves your preferences unchanged. So that's about lexicographic preferences. Now, I want to look at the technical definition here. So what's the technical definition of lexicographic preferences? So the technical definition is, given any two bundles A and B, A will be strictly preferred to be, a consumer I is said to lexicographically prefer X over Y if given bundle A is XA comma YA and bundle B is XB comma YB, then one, either XA is greater than XB or XA is equals to XB and YA is equals to Y. Okay. So in these, if either of these conditions is met, then you will have A strictly preferred to B. So what we are saying is कि या तो amount of X बड़ा होना चाहिए या फिर अगर X same है तो फिर Y बड़ा होना चाहिए. ठीक है. So this is the definition of lexicographic preferences. Okay. Now let us check how it does not obey continuity. So in order to see that, I have to define continuity. So first we define continuity. Okay. So continuity is defined in a way that suppose a sequence of bundles yn, an equals to xan comma yan is such that an is strictly preferred to b, some bundle b, where b is xb comma yb. Okay, then a bundle A, which is basically xa comma ya, such that xa is equals to limit n tending to infinity xn and ya is equals to limit y tending to infinity yn will be basically will satisfy A strictly preferred to B. So what we are saying is that in the consumption set, suppose there's a sequence of bundles A. Okay, such that xn की limit is A, xa and yn की limit is ya. ठीक है, so एक sequence of bundles है like this, which is let's say tending to this point. Okay, so this is let's say the bundle xa comma ya. Okay, so this is my bundle A1, this is my bundle A2, this is A3 and so on, and A infinity जो है, this is my bundle A, limit point of these bundles. So what he's saying is that let's say all these bundles are more preferred, or you can even work it out for less preferred. But the point is that अगर ये सारे bundles more preferred than some other bundle B है, okay, let me take the other way around. Let me take bundles here. ये better होगा. क्या है? Okay, so suppose there's this sequence of bundles which looks like this. Okay, and this is my bundle A. Okay, so this is my A1, A2, and so on, and they are tending to this point. Okay, so the sequence is leading to this point A. A1, A2, A3, and so on. Okay, and this is the sequence. So if all these bundles are more preferred to some other bundle B, let's say that bundle is here B. Okay, so if all of these bundles are more preferred to B, then A should also be more preferred to B. Okay, so ये graphical story है. Now let's look at why lexicographic preferences do not satisfy this. So that example will actually clear this definition also. Okay, so let AN is equals to the sequence 2 plus 1 by n, comma 2. Okay, and Bn is equals to 2 comma 3. Okay, this is true for a consumer who lexicographically prefers good X. Okay, so my consumer he lexicographically prefers good X. So अब अलग-अलग bundles देख लेते हैं. What will be the different bundles now? So what will be bundle A1? So A1 के लिए n की जगह 1 डाल दूंगा. So 3 comma 2. So 3 comma 2 को अगर मैं Bn से कंपेयर करूं, सॉरी Bn नहीं से B है ये. So A1 जो है उसमें amount of X ज्यादा है. So definitely A1 is more preferred. Similarly एक दूसरा बंडल ले लेते हैं A2, which is 2.5 divided by comma 2. So obviously यहाँ पे भी X ज्यादा है. Similarly A3 will be 2.33 comma 2 and so on. So all the bundles will be greater. So AN will be 2 plus 1 by n comma 3, which will be more preferred than 2 comma 2. So 2 plus 1 by n comma 2, which is more preferred than 2 comma 3, because 2 plus 1 by n will always be greater than 2, right? But limit में क्या होगा? What is limit n tending to infinity an? So limit n tending to infinity an क्या होगा? Which bundle will be the limit of this sequence? You'll have to speak up because I can't see the chat. So what will be the limit of this sequence? n को infinity करोगे तो क्या बनेगी इसकी लिमिट?
2.
Yeah, so what is the vector of this limit? इसकी लिमिट what is the vector? n को infinity कर दोगे तो ये पूरा वेक्टर क्या बन जाएगा? Just look at these numbers. This will give you the answer. I want the complete vector, right? I want the bundle
2 comma 2.
2 comma 2 exactly. ठीक है, क्योंकि y coordinate जो है वो मेरा चेंज ही नहीं हो रहा है, so you can call it 2 comma 2. ठीक है, I could have as well tweaked it here a little bit. 2 plus 1 by n कर देता इसको, तो फिर मे बी तुम्हें लगता कि ये सीक्वेंस है, but 2 comma 2 is also a sequence. I'll show you graphically what this sequence looks like in a moment. But before that, analyze this mathematically. This is my limit sequence an. Now compare this with sequence B, which is 2, 3 comma 2. No, 2 comma 3. Which is more preferred? The sequence A or the sequence B? Which will be more preferred according to a person who lexicographically prefers good X? Would A be more preferred or would B be more preferred? Think of Olympic gold medal tally here. अगर एक कंट्री के पास 2 गोल्ड और 3 सिल्वर है, दूसरी कंट्री के पास 2 गोल्ड और 2 सिल्वर है, who will be ranked higher?
B.
B, exactly. So till now all the elements of the sequence were being ranked higher, but now B gets ranked higher than the limit. Okay, so graphically what it looks like is, so in the same graph, if I want to draw this sequence, so 2 plus 1 by n comma 2, so y coordinate is fixed at 2, so y को मैं fix कर देता हूँ 2 पे, and on this y I have different points which look like this. 3 comma 2, 2.5 comma 2, 2.33 comma 2, and so on. Okay, but the limit point is here, which is 2, 2. So the bundles are all to the right of A. So it's like a sequence which is coming from the right to the left to meet my point A. Now, where is my point B? So point B will be here. This will be point B. Okay. So if you compare B and A, they have same amount of good X, but B has more amount of good Y. So B is more preferred than A. But all the other points of the sequence, they are strictly more preferred to B. Okay. So every element of the sequence is more preferred to B, but the limit of the sequence is less preferred to B. So this is discontinuity. So if you imagine it, छोटा सा tweak मैंने यहाँ पे किया. Imagine this very large A1 million. So A1 million is just 2 plus 1 by 10 to power minus 6, comma 2. So this point is also more preferred to B. But when I remove this 1 by 10 to power minus 6, sorry, 1 by 10 to power 6, when I remove this small quantity, suddenly B gets more preferred. Okay, so this small change changes the preference. Okay. So this is why lexicographic preferences do not obey continuity, and that's why they cannot be represented with the help of utility functions. So I cannot talk about utility functions. Okay. So one very interesting property of lexicographic preference is no utility function. Okay. The second interesting property is that there is no, the ICs are singleton sets. What it means is that कोई भी IC में indifference curve में एक से ज़्यादा point नहीं होंगे. ठीक है. Basically, what this implies is that if point bundles A, B belong to the same IC, then bundle A must be equal to bundle. Okay, so let's try to prove this. Prove this. That if two bundles are in the same IC, then they are both equal. Now remember, IC kya hota tha? IC is set of bundles that are indifferent to each other. Right, set of bundles which are indifferent to each other. So do not think of ICs as curves right now. Think of them as sets. So if I can find one set of two distinct bundles which are indifferent to each other, even that is sufficient. Okay. But यहाँ पे क्या है? What I'm saying is my bundle A is indifferent to bundle B, and A and B are different. So what happens is, let's say bundle A is XA, YA, and that is indifferent to bundle XB, YB. So first thing what I show is that in this case, XA has to be equal to XB. Why? Because if XA is greater than XB, then bundle A is more preferred to B. And if XA is less than XB, then bundle B is more preferred to A. So अगर A indifferent to B है, तो ये भी नहीं हो सकता and ये भी नहीं हो सकता. So the only possibility is XA equal to XB. Second thing is YA. Okay, given XA equals to XB, YA must be equal to YB. Because given XA equals to XB, if YA is greater than YB, then A will be more preferred to B. And if YA is less than YB, then B will be more preferred to A. ये दोनों ही चीजें allowed नहीं है, because I want this to happen. So this implies what? XA must be equal to XB and YA must be equal to YB. अब X bundle, X amount और Y amount दोनों same है, then it implies that my bundle A must be equal to bundle B. So two distinct bundles cannot be indifferent to each other. अगर कोई भी दो अलग-अलग point तुम ले लो consumption set में, any two different points A and B, they cannot be indifferent to each other. Any two distinct points will not be indifferent. So every point is a bundle in its indifference curve in itself. हर point बस खुद से indifferent है और किसी point से indifferent नहीं है. So that's the moral of the story. So two very interesting properties about lexicographic preferences. One is no utility function. Second, ICs are singleton sets. Okay. Okay. So with that in mind, I want to now analyze the cases. So remember the cases that I have done till now. Case one was convex with convex. So in this case, my contract curve. Okay, so contract curve was given by MRS of A equals to MRS of B. Okay, and equilibrium भी इसी तरह से निकलता था, solving the two Lagranges simultaneously. Okay, then we did perfect substitutes, we did perfect substitutes convex. Okay, then we did perfect complements. Fifth was perfect complements, perfect substitutes, and sixth was perfect complements convex, which we did not deal much into because, as I told you, perfect complements with convex is not something which is asked because it gets very technical. Now we move to the next cases involving lexicographic preferences. So the first one in lexicographic we are going to do is lexicographic with lexicographic. Yeah. So how does that work? So suppose okay, so suppose this is your Edgeworth box, and this is your origin of agent A. Okay, who lexicographically prefers good X, and this is origin of agent B, who lexicographically prefers good X. So both the agents, they prefer the same good lexicographically. Okay. So start with any point in the Edgeworth box. So take any point in the Edgeworth box like this. Suppose this is the endowment point. Then what does A want? A wants more of good X. Okay, so A bolega, let us move to the right, because moving right means more of good X for person A. Right, so A wants to move right. But moving right means B gets less of good X. So B does not agree to this. So B will say no to this. Because B wants to move left. B says, I want more good X. So this is what B wants. This is what A wants. So the bottom line is there will be no trade in amount of good X. No trade in good X. Because nobody is willing to part away with good X. If you think about countries will not be willing to trade their gold medals. Okay? So dangal dekhiye tumne. Gold is everything. Okay? Gold medal. Nothing else matters. Okay, so nobody would be willing to trade in gold because for trade to happen, some party has to give it up. Here, no party wants to give up the good X. Okay, so X axis ke along trade nahi hoga. So that thing is clear. Now the only trade which can happen is along Y axis. But then again, along Y axis, if you think again along Y axis, it does not happen because B wants to go down. Because down is Y of agent B. This is X of agent B. So going down means B gets more of good Y. But at the same time, A wants to go up. This is what A wants to go because remember, this is Y axis of agent A and this is X axis of agent. Okay, so starting from any point, they cannot agree on any direction of the trade. So this implies that there is no trade in X and there is no trade in Y, which basically implies that no Pareto improvement is possible, which implies that the entire Edgeworth box is Pareto efficient. The entire box is the contract. Okay. So if somebody asks the contract curve in this case, it's the entire Edgeworth. So this is a situation when both people prefer the same good lexicographically. Now let's do the situation where both people prefer different goods lexicographically. So that situation is pretty different. You'll see how. Yeah. So let's say agent A prefers good X lexicographically. Yeah. This is origin of agent A who prefers good X. And this is origin of agent B who prefers good Y. Okay. Now let's start from any point here. Now what A wants is more of good X. Okay, so A wants is said and B wants more of good Y. So B wants go down because remember this is Y axis of agent B. Okay, so in the case when both prefer other goods, okay, when A prefers good X and B prefers good Y, in this case, what we see is a trade in this general direction can make both parties better. So bottom right is the direction for Pareto improvement. So remember हम क्या करते हैं, हम हर केस में दो चीजें निकालते हैं. First we find out what's going to be the contract curve, and next we find out what's going to be the equilibrium allocation and price vector. So starting from this situation, we will try to find out what's going to be the contract curve first. So what is the hunch? Can you tell me any hunch about what you feel the contract curve should be like? Based on everything that we have done till now, do you guys have any hunch ki contract curve kya hona chahiye?
Bottom right corner.
Bottom right corner, okay. So let's test if bottom right corner is the contract curve first of all. So if you are at this corner, then obviously A has all of good X. So what's happening at this corner is that A has all X, okay, and B has all Y. Now, for any Pareto improvement to happen from this point, a trade should happen, and any trade will require A to part away with his X, which A will not do, or B to part away with his Y, because that is the only thing he has to trade. So that will also not happen. So that is obviously true that starting from this position, no trade happens, no further trade, which implies no Pareto improvement. Okay. All right. So that's clear that this point is definitely Pareto efficient. What about this point? Is this point Pareto efficient or not?
No, sir.
Why? Can you tell me a Pareto improvement from this point onwards?
So there can be a Pareto improvement towards right direction because B will be indifferent as he
Okay.
has the same amount of Y.
Why will B be different? B prefers good Y. So imagine this bundle is 5, 0, and this bundle is let's say 10, 0, and this point is 10, 10. Right? So so at this point, the bundle that B has, okay, if you talk about the bundle that B has at this point, the bundle that B has is 0, 10, and the bundle that B has here is 5, 10. So what does B prefer, 0, 10 or 5, 10? What will B prefer?
5,10.
5, 10. So if you move from here to here, B gets worse off, right? So B will get worse off because you're moving him to a lower utility bundle. So that's why in this situation, this trade will not be Pareto improvement, because remember the two conditions for Pareto improvement. Okay, the two conditions for Pareto improvement was no one gets worse off, and two, at least someone better off. So this condition itself is not met because B gets worse off when you move from 5, 0 to 10, 0. Right. So this is also Pareto efficient. So this point is also Pareto efficient. So I can argue this for this entire bottom corner as well as the right corner. So your hunch is correct that this is Pareto efficient, but your hunch is incomplete because these points are also Pareto efficient. Now remember, whenever you're making a hunch, always try to think big, because then you can eliminate things. Okay. So you can even start with the hunch that the entire edgeworth box is Pareto efficient. फिर तुम हर edge पे ले लेके you can start rejecting कि ये नहीं है, ये नहीं है. Okay. Mostly, so if you get a question, it should be from one of the cases that I am discussing with you. But if you get a new type of question, that's an opportunity, because others might not get it, but you know how to do it. It's not going to be easy doing it in an exam, but that's what the exam is testing. Do you understand the basics or not? So you'll have to test different points. You have to begin with some hunch, and don't start with a small hunch like just one point. Always try to have a bigger hunch, like in this case, this, or you can even take the entire box to be Pareto efficient. And then you can start rejecting. After you take cases, you will find out that this is not Pareto efficient, this is not Pareto efficient, this is Pareto efficient, this is Pareto efficient. Okay. So that's the contract curve. So your contract curve basically is this thing, the right and the bottom borders. Now let's talk about equilibrium. So when we talk about equilibrium, we'll again start with some random random endowment point, and then we'll look at different budget lines. Okay. So suppose this is my endowment point. This is origin of agent A who prefers good X. This is origin of agent B who prefers good Y. Now let's begin with some arbitrary budget line like this. But before that, what I want before that is consider a person with lexicographic preferences. So suppose this is the budget line of a person with lexicographic preferences. Okay, obviously यहाँ पे और यहाँ पे खत्म हो जाएगा. Okay, so if this person lexicographically prefers good X, what point on the budget set, you know the budget set, right? The budget set is this entire time. What point on the budget set will this person consume? This is good X, this is good Y. What point on the budget set will this person consume?
All of X and none of Y.
All of X and none of Y, which technically we call as the X intercept. Okay, so this is the point this guy will consume, his X intercept. Similarly, if you would prefer good Y, okay, अगर वो good Y को lexicographically prefer करता, then he would go for this point, which is the Y intercept. Okay, so if you lexicographically prefer good X, and if you are able to buy it, then you will spend money to buy all of good Y. Okay, and not of good X. So in this case, now with that in mind, let's come back here and let's start with some arbitrary budget line. So if we start with this arbitrary budget line now, which looks like this, एक काम करते हैं, line पहले draw करते हैं. Okay, so this is some arbitrary budget line on this endowment point E. Okay, so agent A prefers good X lexicographically, so he will go with his X coordinate, right? So X intercept, so it's going to be this one. This is XA bundle. Okay, and agent B, he prefers good Y, so he will go with his Y intercept, so it's going to be this bundle, so XB bundle. So they both prefer different bundles on the edge box. So obviously this line is not an equilibrium budget line. So how should it move? So to understand this, let's talk about X's demands. So good X ka demand is coming only from person A. So this is the demand. The total supply se wo kam hai. Total supply is the width of the H1 box. So obviously there is excess supply for good X. Okay. So by Walrus law, I know that there will be excess demand for good Y. So wo dekh lo. This is demand for good Y, which is more than the total supply. Total supply of good Y is only this much. So there is excess demand for good Y. So this implies Px must go down, and this implies Py must go up. So Px upon Py as a whole should reduce. So this line should get flatter. Okay. So similarly, you can do analysis for a budget line which looks very flat. Okay, which probably looks something like this. So you can do an analysis for line like this, and you will find the reverse would be true now. That there'll be excess demand for good X and excess supply for good Y. So ultimately, you'll come down to this understanding that in equilibrium, what needs to happen is this thing. The budget line should pass through this point. Okay, so this is what should happen in equilibrium. So in equilibrium, if you're starting from a point that is not on the bottom or the right edge, then the only thing which can happen is that the equilibrium allocation, it needs to be the bottom right corner. Okay, so if you're starting off from any point, like here, if this is your endowment point, your equilibrium allocation should definitely be this. This is your final equilibrium X. If A prefers good X and B prefers good Y. So iske baad you can find this price vector very easily. You can find this point. This point will be given to you XA comma YA. This point will be XA plus XB comma 0. So this slope can be easily found. Minus Px upon Py is delta Y by delta X. Okay, so let's do an example so that it becomes clear ki karna kaise hai. So let's do a simple numerical to understand ki karna kaise hai. So the example is A lexicographically prefers good X, B lexicographically prefers good Y. This guy's endowment EA is equal to 2,5 and EB is equal to 8,8. 12,8. 12,10. Sorry, 10,10. So first, what is the equilibrium allocation? And second, what is equilibrium price vector Px upon Py.
Equilibrium
first-
allocation is
Yeah,
12,0.
can you repeat? I
12,
couldn't hear you.
0.
12,0. And so xb vector will turn out to be 0,70. Good. And what will be the price vector, equilibrium price vector?
1/2.
1/2. Very good. So what's happening is that this is my xa vector. This is my endowment vector. So if I find delta y by delta x, so delta y by delta x will be equal to, compare this bundle, which is my starting point, with this bundle, which is my ending point. So इससे मैं delta y by delta x निकालूंगा. So 0 minus 5 upon 12 minus 2. So this is minus 5 by 10, which must be equal to minus px by py. Because remember, slope is minus px by py. So 5 by 10 is minus px by py. So px by py must be equal to 5 by 10, which is 1 by 2. So you can find equilibrium allocation and equilibrium price vector very easily. Okay. Now let's talk about lexicographic with perfect complements. So what happens with lexicographic and perfect complements? So graphically, what point does a person with perfect complements choose on the budget line? So given budget line and line of vertices, what point will a person with perfect complements choose? Don't you remember? Suppose agent A lexicographically prefers good X and agent B is perfect complements with this as the line of vertices. And suppose this is my endowment point. Okay, suppose there's some endowment point like this. So if I consider this budget line, what point will person B pick as utility maximizing bundle?
So the intersection of the budget line and the line of vertices.
Very good. Okay. So I'll come back to this later. First, we have to understand about, first we have to talk about this contract curve. Okay, so always first thing we'll deal with is contract curve. So B's IC from here looks like this. This is IC of B, ICB. Okay, so what makes B better off is going below his IC, which is this complete region. And what makes A better off is going to the right, because he prefers good X. So if you draw this line here, he prefers anything to the right. Anything to the right is more preferred. So you basically get this rectangular region as your, this region is your Pareto improvement. Is this part clear? Pareto improvement. Okay, so whenever you have a doubt, you have to raise it right away, because I don't have chat access today. So you'll have to stop me there itself. So this is my Pareto improving zone. Okay, so I can remove everything else Okay, so starting from this point, this will be my Pareto improving source. So trade should take me in this direction. Right, so should take me in this general direction. What about a point like this? Suppose you are at this point. This is your endowment point. Can you think of any Pareto improvement starting from this point?
Yes, sir.
Can you tell me which one?
Sir, in upward direction.
Very good, upward direction. Perfect. Okay, so these are the kind of things you have to think in an exam. Okay, kahan ho sakta hai? So obviously, what A wants is going right. What B wants is going here. कोई intersection नहीं है. So going right or left is definitely not possible. Okay, then you have to think about going up or down. Right. So going up or down, either way, you're moving along the IC of agent B. So B is indifferent. So any movement up or down is indifferent for B. So then the question becomes, what is better for A? So obviously going up gives A more of good Y. So this movement going up is Pareto improving. So it will go up till this point. इसके ऊपर और नहीं जाएगा because then B is no longer indifferent. B starts getting worse. Right. So this is the threshold of how high you can go. Okay. So starting from here, you want to go in this direction. Starting from any point below this line of vertices, you want to go up. So what is the hunch? What could be my contract curve? So starting from any point downwards, you go up. Starting from any point here, you move here. So what is the hunch? What is the contract curve? These arrows, they can help you
The line of
deciding what is
vertices.
Very good, line of vertices. ठीक है, so line of vertices is definitely the contract curve. ठीक है, इसको check करने की जरूरत नहीं है. I mean, you can check it definitely, but abhi, because we have done many such cases, you know how to do it. So I'm not just checking why it is line of vertices. The important thing is building a hunch. एक hunch बनाना जरूरी है, because you know we are doing a lot of different cases and I do not know कि exactly क्या case पूछेंगे वो तुमसे exam में. So the important thing is not to be remembering each and every case, but to understand हर case को deal कैसे करते हैं. If you remember, great, you can do the question in 5 seconds. If you can't remember it and if you remember the trick, you can at least take 2-3 minutes and do it. You won't be at a loss. Okay, so that's important. Second thing is, okay, is this section Pareto efficient or not? ये section अब मुझे check करना है. Is this section going to be my in the contract curve or not? So for that, take any bundle here like E. Okay, and then analyze E से कोई Pareto improvement possible है कि नहीं. So is it possible to do any Pareto improvement starting from point E and in which direction? This is ICOB.
So in the right direction.
Very good. So moving from here to here is Pareto improvement, because again you are giving X to A, so A gets better off, but B is moving along his IC, so B is indifferent. So one person better off, the other person indifferent. It is a Pareto improvement. So this point is not Pareto efficient. So only this line segment is Pareto efficient. This part is not. Okay, this part is not Pareto efficient. Okay. Now that's about contract curve. Now let's talk about equilibrium. So this is my jewel box. Now to talk about equilibrium, again, this is origin of agent A, who lexicographically prefers good X, and this is origin of agent B, whose perfect complements. This is the line of vertices. Now, what you know is that given any bundle, agent A wants to pick the x-intercept and agent B wants to pick the point where the budget line hits the line of vertices. So once you know that simple trick, उसके बाद question बहुत easy है. ठीक है? So let's start with an endowment point. यहाँ पे दो cases होंगे. One case is in this region, the other case is in this region. So let's start with this region. So let's take an endowment point here. Budget line अगर मैं draw करूँ, okay, then A demands his x-intercept. So this is going to be x A vector. B demands the intersection. So this is going to be x B vector. Okay. So total demand for good x will be this plus this. Okay. So अब मैं shortcut में करूँगा सब कुछ. So I am only analyzing good x. Why? Because I know कि by Walrus law y के लिए automatically excess demand या supply हो जाएगी, जो भी x से हो रहा है उससे opposite. So I know there is excess demand for x, which implies px must rise, which implies px upon py must rise. So this budget line should get steeper. Okay, steeper till what point? Till this point. यहाँ तक steep होना चाहिए. Once it becomes like this, then what happens is this becomes XA vector and this also becomes XB vector. So now both of them demand the same point on the budget line or on the Edgeworth box. So that becomes the equivalent. Okay. Now, next up, let's analyze a point in the other section. So let's do this section. So now if you have this as the budget line, then obviously A prefers this bundle XA and B prefers this bundle XB. So good X की demand इतनी plus itni. So obviously X is demand for good X. So Px must increase, Px plus Px upon Py must increase. Okay. So budget line should get steeper. All right, and this should be true for all levels of budget line. So किसी भी budget line के लिए Px should keep getting steeper and steeper. So eventually what you see is एकदम बहुत ऐसे भी ले लोगे तो भी you will see Bx must rise. So the ultimate thing which can happen here is a vertical budget line. A vertical budget line means Px upon Py is infinity, which implies Py is equals to 0, which means good y is 3. Okay. So this is IC of agent B through this point, right? So in this case, this is the IC of agent B. Good y becomes 3, but giving up y will put B on a lower indifference curve. This is a lower indifference curve. So B will not part with his Y. ठीक है, B Y नहीं देगा और A तो X कभी देगा ही नहीं. ठीक है, A will never give us X. That is pretty much clear because A lexicographically prefers code X. Right. So this is more like a stalemate kind of a situation wherein we cannot figure out what is going to be the equilibrium allocation, or what it tells us that the only equilibrium price vector which is possible is good Y becoming P. Okay, so in this case, this becomes the equilibrium allocation. In this case, good Y becomes P. That is all we can say. Good X की demand is this and this, yeah. This plus this. This X's demand. Yeah. Okay. Now let's do the case of perfect complements, perfect substitutes with lexicographic preferences. Perfect complements, perfect substitutes with lexicographic. So agent A lexicographically prefers good X. Agent A lexicographically prefers good X. So he has no ICs. Agent B is perfect substitutes. So his ICs, they will look like this. Now, what happens is if you take any budget line. Okay, sorry, first contractor. So contractor की मैं बात करूं, so A wants to go to the right. Right, so A wants to go to his right, which is this entire region. B wants to go below his indifference curve, which is this entire region. Okay, so the intersection is this triangular region. This is your Pareto improving zone. So trade takes me bottom and right. So the first thing I want to ask you is the hunch. What is your hunch? Where should trade? What should be the contractor?
The bottom side.
Okay, bottom edge. Good. But like I told you, always be a little broader. थोड़ा ज़्यादा error करने के लिए ready हो जाओ. So can you give me a larger set than just the bottom one? Think a little more than just the bottom. That is what I'll tell you. You're correct, but you are restricting yourself. What you see is that the angle is bottom and right.
Bottom line.
So you see this is going bottom as well as right, not just bottom. A bottom arrow looks like this. This is bottom and right. So can you give me a broader answer than just the broad bottom line?
The bottom edge and the right edge.
Very good. Okay. So, okay, maybe you are wrong right now, but at least you are thinking big. Then next step would be to analyze each and every one. Okay. So let's come here. Let's come to a point like this. So obviously starting from a point like this, agent A wants to move right. So agent A wants to go here. Agent B wants to go below his current indifference curve. So that is this region. So obviously now right जा सकते हैं, now left जा सकते हैं. So this point is Pareto efficient. Similarly, come to this point. Agent B wants to go here. Agent A wants to go here. So obviously there is no intersection here. Can they go down? If they go down, agent B will be giving up some amount of good Y for, sorry, agent A will be giving up some amount of good Y to B for free. He will be donating good Y. But he's not going to donate anything, because if he doesn't get X, just losing Y makes him worse off. So he does not want to give up anything for free. Okay, so free में तो वो कुछ नहीं देगा. So that cannot happen. So obviously moving down is not an option. Moving up makes B worse off. So that is also not an option. So nothing can work out here. So this part is also Pareto efficient. This part is also Pareto efficient. So ultimately the bottom and the right edges are Pareto efficient. Okay. So that's about the contractor. Now let's talk about the equilibrium. But before that, why don't you tell me, if this is the budget line of a person with perfect substitutes and these are his ICs, what point does he pick on the budget line? The x-intercept or the y-intercept?
X-intercept.
X-intercept. Okay. So remember this, whenever slope of budget line is greater than slope of IC, he picks the x-intercept. And when the reverse is true, y-intercept. Okay. So this becomes important when we analyze equilibrium conditions. So let's build another Edgeworth box first. In this, you have origin of agent A who prefers lexicographically good X, and origin of agent B who lexicographically prefers good Y. Sorry, who's perfect substitutes. Okay, so these are his ICs. Forget them for now. कोई भी एक endowment point ले लो like this. Now starting from point E, what happens is, so from this point, agent A's IC, let's say, looks like this. This is A's IC. Sorry, B's IC. IC of B. Yeah. Now, if I take any random budget line, which looks like this is the budget line, let's say. So when slope of budget line is smaller, okay, so now what's happening is slope of budget line is smaller than slope of IC. So he will pick the y-intercept. Right, so he's going to pick the y-intercept. So B picks his y-intercept. So this is the point which B picks, X B vector. A always picks his x-intercept, so he picks this X A vector. So they both pick different points, so that's why no equilibrium. So as you can clearly guess by this point, the only thing which can give me an equilibrium is a budget line which passes through this point. So this is my equilibrium point. Okay, this is my equilibrium point. Because if you take any other budget line, the points will be different. They'll start demanding different points. Okay, so they will demand different points for any other situation. Okay. Now let's take a situation like this here. No, not here. Yeah. Okay, yeah. Sorry. Okay. Let's take this situation. This is the endowment. Then obviously I cannot take this as the budget line, because moving from here to here, oh no, sorry, you can take this as the budget line. Wait. Sorry, forget it. Forget it. What I wanted to say is this is IC of B. I should have done the other case first. Forget everything. Let me do this case first. उल्टा कर दिया मैंने थोड़ा सा. Suppose you this is IC of B and the endowment point is here. Okay. So in this case, what happens is if you draw any line, any budget line, like here. Okay. So agent B, this is the budget line, let's say. ये उल्टा बनाया था मैंने इसलिए गलत मिला मुझे. This should be reverse. यहाँ पे slope of budget line is flatter. Slope of budget line is lower than slope of IC. इसलिए मुझे गलत result मिल रहा था. I'm really sorry. ठीक है. Slope of budget line जब less than slope of IC है, then you get the x-intercept. Here we have this situation. Okay, so budget line का slope is greater than slope of the IC. So in this case, B picks the y-intercept, which is this point. A always picks his x-intercept, so this becomes the equilibrium point, and that is fair enough. Okay, so this is going to be the only equilibrium possible. Okay. Now, what about when you have a situation like this? So this is your another IC of agent B, and your endowment is here. Now, if you take this as a budget line, okay, so pushing him here is going to make him burst off. यहाँ ले लेता हूँ endowment on this particular IC. Then you cannot push him on this point, because you know this point is on a lower indifference curve. For B, he'll be moving to a lower indifference. So B does not make this transition. This cannot be an equilibrium. So अब कोई steeper budget line होना चाहिए. So if you take a steeper budget line which looks like this, okay, then what happens is A picks his x-intercept, which is this point. And now the situation is slope of budget line is greater than slope of indifference curve, right? Budget line is the black line, red line is the flatter line. So in this case, he picks the y-intercept. B will pick the y-intercept. So the point which B picks is going to be this point. यहाँ पे कहीं पे y-intercept. So the only possibility is that the budget line should coincide with the indifference. Then A picks this point, B is indifferent everywhere. So then they both agree on this point. Okay. वैसे अगर horizontal budget line लोगे यहाँ पे, if you take a horizontal budget line like this, and this is, let's say, color. This is, let's say, the IC. Then slope of budget line is smaller than IC, so B wants to pick his x-intercept. So x-intercept तो यहाँ पे कहीं पे हो जाएगा. This will be the x-intercept for B. So obviously he picks a very different point. Okay. So in this case, one thing is pretty clear, that the price will be decided by what is the position of the endowment point with respect to B. Okay. So in a situation like here, Px upon Py will be decided first, which will be equal to MRS of agent B. In a situation like here, the equilibrium point will be decided first, which is BA gets all X. So where you are with respect to the indifference curve passing through this point. Suppose this is the indifference curve passing through this point. So in this entire region, this situation will happen. And in this entire region, this situation will happen. That the price gets decided first. In this entire region, this thing happens. All right. Again, perfect. Now the last thing left is, so mostly I expect them to ask contract and things like that. In numericals, इसमें देना मतलब तुमको graph बनाना पड़ेगा and all that thing. So it gets pretty messy, but they have done it in the past, so it's not out of syllabus. I'll still expect it with a lower probability to happen, and that's why I'm spending time doing it. Otherwise, मैं क्यों अपना time बर्बाद करूँ, right? So I'm doing it only because I expect it to be asked. So I don't want you to be shocked in an exam कि ये क्यों पूछ लिया. Be prepared कि हो सकता है पूछ ले. Now the last thing is lexicographic with convex. Now this is something which has never been asked. So इसको मैं expect नहीं करता that any exam will touch, because again very complicated. So analytically you can see what can happen here. So again take A as the guy having convex preferences, let's say. So origin of agent A has Cobb-Douglas preferences. So ICs will look like this. And then origin of agent B, who lexicographically prefers Codex. Okay. So starting from any point here, like this, if you have any point, then what does B want? B wants more of good X. So B wants to go in this general direction. And A wants to go above his IC. So this is the common region. Right. So in this common region, you will see Pareto improvement. So Pareto improvement, ये बड़ा वाला ले लेते हैं. So Pareto improvement should take me in this direction. Okay. So you are going top and left, top and left, top and left. So what is the hunch?
Left edge.
Very good. Top edge and left edge, right? So that should be the hunch, top and left. Okay. So if you're getting hunches correct, that means you're on the right. After that, all you need to do is check it. If you are not feeling confident, take the entire edge over box and check it. Okay, you can take the entire edge over box and check it. Doesn't matter. The idea is that it will be one of the corner points, because agent B always picks a corner. Agent B with lexicographic preferences is always better off on the maximum amount of codex. So कोई भी budget line हो, वो zero amount of codex कभी prefer नहीं करेगा. If he can buy, he'll buy whatever possible quantity of codex. ठीक है? Are you guys still able to see me? Or the screen?
No, sir.
Can you see the screen?
Yes, sir.
Okay.
Yes, sir.
Webcam. Fine. Anyway, we have done all the cases now. So you can start with the past years. There are a lot of good questions in the past. So the best questions are in the past years. I'll try to make solutions for these concise solutions, and I'll add them in a couple of days so that we don't have to take a doubt session and you guys can go through the doubts as per your wish. And I'll also make solutions for, I'll make solution videos, by the way, not typed solutions. I'll just make solution videos along with the answers. So answers you can see, and the videos will give you the solution if the answer is match. Okay, so that will take me a couple of days. And then we'll meet for quasi-concavity and quasi-convexity lecture tomorrow. Okay. All right then. Let me end the lecture then. Okay. Fine. So I'll see you guys tomorrow for quasi-concavity and quasi-convex. Ending the lecture now. Bye guys.